All right. Well, it's Monday, which means I get to go online and stream with somebody interesting. So, Sebastian, good evening. It's evening for you. Thank you for hanging out with me here in the early evening your time. It's actually quite pleasant weather finally for me here in the Twin Cities. So many times I've been doing this and it's been cold and rainy. So I'm delighted that it's not. But good evening. Thanks for joining me. Appreciate having you.
My pleasure.
Outstanding. So, for folks who aren't familiar with you, can you give us kind of your overall bio, how you got into this whole software space, things of that nature, and then we'll jump off from there. I know in our pre-show we have I think a pretty good list of things to dive through, but I
Mhm.
always like to start with bio. So, how'd you get here? What brought you into this strange world known as software?
I started to work in a company called Worldline, and there I work on some pretty interesting project. Like I was responsible for the Louvre Museum website
Oh,
or
heck
the
yeah!
French Geoportal technical infrastructure. So basically, French Geoportal is like French Google Maps. And so I worked, I think, around 10 years there, and I was leading a R&D a thing called Innovation Labs, and here we created some open source projects. And I co-created with other folks a project called RESTHub, which was a kind of precursor of Spring Boot on open source side, and that was for some reason the Spring team, some members of the Spring team found this open source work, and I get an interview along to Brian Clausel, who is also a member of the Spring team, and both of us get hired in the Spring team. And yeah, it's almost 10 years now. So I have been part of the Spring Framework core team, so contributing improvement in the web part, so Jackson support. I led the introduction of Kotlin support in Spring because I like this language. And more recently, I have been doing a lot of works around introducing GraalVM native images support by leading the Spring Native experimental project that has now been, this work has now been integrated in Spring Boot 3. And I'm generally interested into, making Spring Boot applications more efficient to run in the cloud, cheaper, more sustainable, and I do various work around that area.
Outstanding. Well, let's see here. We've already got good old Glenn is there. Good afternoon, Glenn. Thanks for joining us. I was going to give you grief if you didn't show up, so thanks, Glenn. Glad you're here. And Simon's here too. Good evening, Simon. Good to have you as well. So, what is it about Kotlin that caught your attention? That's an interesting thing that you helped bring Kotlin into the whole Spring ecosystem. I always thought that was one of the things I really liked about the JVM, that we had a lot of different options in that space. We weren't just limited to one language. So, what brought you towards Kotlin?
I think the initial angle was having a better Java. I mean, when I start working with Kotlin, Java did not have records or various other features that he has recently gained. And in fact, one of the things I am the most proud of is I think the adoption of Kotlin on the JVM has pushed Oracle to be a bit more aggressive on Java side in terms of language features. And so, yeah, I really like this language. I love the feeling. I love the fact that you can write some code that seems as concise as scripting languages. But in fact, this is a truly statically typed language. It's even more statically typed than Java because you have this null safety that is directly checked at build time. So, and this is maybe one of the area where Java still lags behind. You don't have this null safety. You have some various effort to introduce that via notation, but this is not yet a first-class concern from Java, sadly. But yeah, more concise, more efficient, just a joy of developing. Like when you use Kotlin streams versus Java streams, that this is not the same pleasure,
Sure.
I think, as a developer. And yeah, I think it does bring a lot of improvement that make your code safer, more concise. And one of the very clever thing Kotlin bring is this extension mechanism that has allowed frameworks like Spring to almost natively integrate Kotlin just on top of the current Java support. So you don't have to have the Java API and the Kotlin API. Kotlin API is just a superset of the Java one, and we provide just a few Kotlin extensions to make it look like Spring is a Kotlin framework, while most of it is written in Java. So I think the initial angle was really this better Java language. It's true that Java has evolved quite a lot and is now much better language, records and other similar features. And so nowadays, I think Kotlin interest is also the fact that it is a multi-platform language. It's not only targets the JVM, but it also targets native, the web, etc. And that's maybe an area where it could really differentiate from Java, in addition to the null safety and other features that are really Kotlin specific.
Yeah, I've been in the Java ecosystem a really long time, and I remember when it sort of stagnated, I think would be the polite way to put it, as Sun was sort of figuring out what to do and how to move forward, and where's Java going to land as Sun circled the proverbial drain. And I mean, there was a lot of jokes about, oh, Java's dead. And then, of course, the response was, well, dead like COBOL, since there's billions of lines of it out there. But I have been very heartened by how much the language has evolved over the last 10 years, frankly. I think a lot of that has to do with pressure from languages like Groovy, JRuby, Kotlin, et cetera. I think that's honestly a positive thing. But I was pondering this as we were chatting beforehand about the new versions of Spring and Spring Boot. And I think a lot of people don't always appreciate how hard it is to add features to something that's been around that long. And so I think about Java in that regard. And I remember talking with Brian Getz when they were trying to introduce, Lambdas. And it's like adding that one feature seems so easy, but there's all those ripple out effects. And it's how does that feature interact with everything that's been there for the last 10, 15 years? And there's a lot of effort and energy that goes into making sure that this one thing doesn't break everything else.
Yeah.
And, I do think that that's something that isn't always appreciated by folks who use these tools.
Yeah, I totally agree. And even at framework level, not everybody understands how hard it is to add something without breaking the existing ecosystem. And this is a key added value that we try to provide in Spring from the beginning. And at language level, that's significantly harder because everybody is relying on your stuff. So I truly agree that it's super hard to introduce new features or to, you can't change existing features. So what you introduce is here to stay, and
Right.
you need to live with your choices for the last 20 years, and you need to add something else which is consistent with the existing stuff, and that makes sense for developers using this new feature. And that's super, super hard. So I totally agree with that.
Yeah, as Neil says, this isn't your father's Java. I totally agree. That's a great point, because you spend a lot of time in the native space, and to me that's so interesting, because Java began at its core with the idea of a JVM, and that there isn't that native image, that the JVM is that layer, and then now we've had this migration towards now that's an option. What are some of the challenges that go into taking something that was designed to have that JVM layer and now we're going down to machine code, and what are some of the consequences, positive and negative, for doing something like that?
Yeah, so it's true that lately Java has been a bit challenged in terms of runtime characteristic because on the cloud, typically when you want to run on serverless platform, function, etc., you want to have fast startup and peak performance available immediately. And this is, the JVM is amazing, amazing performance. I keep being surprised by how fast it goes. Like recently, I tried to do a REST version of the famous Spring Pet Clinic application to compare performances, etc. And I'm not a REST expert, but this Pet Clinic application, I worked on that with Ria from the Spring team. The Java version, the Spring Boot version, was running faster when the JVM is warmed up with more memory. So I'm not comparing. Rust is much more efficient in terms of memory consumption, etc. But if you give it enough memory, if you have a warm-up JVM, the JVM is super, super, super fast, even if Java is a very high-level language. So we need to appreciate that. At the same time, with containers, what there is inside the container from a cloud platform is basically hidden. It's a black box. So what you have is how fast my container is able to serve requests after starting it. How many memory and how predictable the memory consumption is, this kind of thing. And here, Java has been a bit challenged by other technologies because the goal is to just have cheaper hosting and also more sustainable hosting. And I mean, if you are building something like Netflix, sure, you just need a bunch of JVM servers running super fast. And but if you are running a back office for a small middle-sized company, if you are running some functions on serverless platforms, if you have some cache layer in your microservices architecture and half of your microservices are doing nothing where there is no cache invalidation, you are just paying for something you are not using, and that's where technology like GraalVM native images provide very different characteristics. So
Right.
I think the first change is that instead of chipping the JVM in your container, you are just going to chip a native executable. So advantage, it will start super fast. It will have peak performance available immediately. It will have smaller memory consumption, but you are back in a world where what you build is architecture specific.
Right.
So you have an executable that is specifically designed for your operating system, for the CPU it runs. There is no cross compilation. Long build times, etc. So it just different trade-offs, and you are losing in terms of flexibility, and you are gaining in terms of my application is up super fast, ready to process requests at the cost of maybe slightly slower performances in terms of throughput, like the JVM, a warm-up JVM, again, there is almost nothing as fast as that. So since there is no JIT, no dynamic optimization when you are running native images, it's a bit slower, but you can basically provision more instances. So it's just a different way of scaling your performances.
Right. And I think that's a really important thing for people to understand is it's just a different set of trade-offs. And all of these are tools. There's times where it's the right answer to still run in the JVM. There's times where it's the right answer to make it a native image. And, one of the things that I've reflected on a lot over the last few years is when we get really dogmatic about anything, especially in technology, but I think it frankly applies much wider than that, we tend to end up in some bad places. And when we look at this as, well, this is my one hammer to solve all problems. No, you've got a whole bunch of different choices. And I think it's, as Glenn says here, you got to know what your goal is, know what the trade-offs are, and then use the right tool for the job. And so I think I appreciate that we have this additional quiver, or this additional arrow in the quiver. Now, of course, that does then pose the challenge of, well, when should I use a native image? When should I stick with the JVM? Are there any thoughts you've got around that particular set of trade-offs?
Yeah, when I do some talks about that, I try to share the why. So scaling to zero, cheaper hosting, more sustainable. And also, when this is a good idea to maybe try that, when you should test and assess if that's a good case for your use case, or if generally the JVM is better. So the use cases where that's recommended, it's basically you have a very cheap instance, one CPU, not a lot of memory. I mean, the JVM has really been designed to have at least 2 CPU and a bunch of, let's say, 2 GB of memory with modern enterprise stack. If you have smaller instances like one virtual CPU, just run native because your JVM instance will take too much time. If you want to run on serverless platform functions, for those kind of use cases, native is just, I think, not a no-brainer, but recommended. If you are running microservices, back offices that does not require crazy throughput, application where you deploy your product as a container image, maybe you should try if native image is a good fit or not. And also it depends about what kind of libraries you are using, because something I have not mentioned yet is that you need some reachability metadata to run your application on native. To basically, there is an ahead of time compilation of your Java code, and if there is some reflection involved, it needs to be configured. So there is some some libraries where this is supported, some libraries where this is not yet supported. And so it's all about the dependencies you are using. And if you are using, if you have a lot of memory and CPU available in your runtime architecture, if you are still using big monolithic application or for various use cases, then the JVM, or if you need high performance, high throughput, with no issue to provision various JVM servers to provide this workload, JVM is likely better. So we try to share some typical use cases to help developers to decide what is the better fit for them.
Yeah, Glenn, you're correct. Han has decided to join the conversation, so he is now going to pair with me on this interview. So at some point, he'll probably bump the microphone, or hopefully he won't grab the keyboard and decide to cancel everything. It's always fun having cats. Let's see. I had another thought here around. Did you see the article that came out from the Amazon Prime folks where they said, hey, we started with Lambdas. Turns out that was a bad idea. We did everything much cheaper using just stock, instances. There were some hot takes that came out pretty shortly thereafter that seemed to boil down to, see, not even Amazon knows how to use Lambdas. No one should use functions at all, which I think is, again, dogmatic as opposed to being more pragmatic. Feels to me like they made a bad architectural decision, or they didn't know the full consequence of the architectural decision, and then they changed it when they discovered that there was another approach. I give them kudos for being willing to, okay, let's rework that, as opposed to, oh, we've already sunk a bunch into this, we just got to keep going. Did you any reflection on some of those kinds of things that have been coming up lately?
Yeah, I'm not aware about all the detail of the blog post, but I saw that, and like we said, if you are dogmatic and if you are using native or other technologies without properly thinking or experimenting, if that's a good use case, it could have bad impact. And speaking about serverless platform, I mean, serverless is interesting because of its billing model and its pay as you use. So if you are using a workload that is a good fit for serverless, like per request or large portion of time where you don't use your platform, I think that's a good fit. But serverless platform make also developers captive of a specific cloud vendor if you are just using direct APIs. I usually think there is, especially with Java or other languages, quite a lot of configuration, etc. So I think I like the billing model. I like the fact you don't have to worry too much about your platform, your servers. But I think scale, what I call scale to zero, is a kind of generalization of the pattern we see on serverless platform, where you can not only scale your function to zero, but you can also scale your regular application. Maybe this is not a per request billing, basically just pay for the period of time where for the last 2 minutes you had some workloads to process, like some HTTP requests, etc. And I have the feeling that the Kubernetes platform that we see with some solution like Knative, Contour, etc., evolved to provide scale to zero capabilities like the serverless platform, but in a more flexible way that you can deploy on-premise or in your cloud provider. But yeah, for not just for functions, so you don't have to change your programming model to leverage that. You can, I mean, I don't say there is no impact on your application, but if that's a cloud-ready application, you should be able to deploy it in a scale to zero fashion in your Kubernetes platform. And this is what is really interesting to me, because you are not tied to a specific cloud vendor. You can deploy it either on-premise or on the cloud, and you can just optimize the cost and the efficiency of the millions of existing application, and that's my area of interest these days.
Yeah, that's a great point. I think there's a lot of misunderstanding of where best to apply functions, serverless, or whatever you want to phrase it. And I think, to me, they make a lot of sense in those scenarios where latency isn't important and the calls are really unpredictable. And my favorite go-to is notification of account change or something like that. You updated your phone number, your password. We're going to notify you of that. Whether you get that notification in 10 seconds, 30 seconds, a minute and a half, probably not super useful or important. And it doesn't matter if there's a little bit of a startup cost to that when we warm up that VM or throw that into a container, depending on how it's done on the provider of choice. And I've seen some people say, well, so you can't use Java for that because it's too slow. And I always think that that's not the right way to think about it. If latency is your problem, then serverless is probably not the best choice, because that's part of the trade-off that you're making there with, yeah, it'll scale up and scale down to zero, but you've got to understand what that impact is going to be on the end user. And if it's going to have a direct impact, then there are other options that we have in the toolkit. Don't, again, be so dogmatic about these things.
Yeah, and usually when I see serverless comparison of various technologies, there is sometimes a naive usage of Java, like they just take a cold GVM that take a few seconds to start. There is no usage of native or snap start or checkpoint restore from Project Crack, etc. And I think these days, at least if you are comparing various technologies, don't use a cold GVM. That makes no sense at all. So sure, a cold GVM is slow to start, slow to process request.
Well, slow is relative, though, right? I mean, this is another one of those things I think is so crazy about how our expectations have changed. A few seconds, not that long ago, we would have been like, wow, this is up and running in 3 seconds. And now we're like, oh my God, that took 3 seconds. Why wasn't it 300 milliseconds? Okay, again, I mean, I would argue that in a latency sensitive scenario, I shouldn't be using functions at all. And if 3 seconds is going to be that much of a deal breaker for me, maybe I should pick a different solution. But I mean, that's a good point, right? That slow has gotten relative, and we've kind of changed the way we've thought about some of that. And a lot of it is kind of an oranges to apples comparison.
That's very true. I mean, I won't name the technology, but I remember of a very old technology working on Java. It took, I think, 20 minutes to start the servers, and there was 2, 3, 4 servers, different servers to start, and that was kind of crazy. So indeed, depending of the context and what we are comparing, a few seconds is already good. And we are just progressing, and basically, it's pretty exciting to be able to leverage our existing stacks with capabilities to start faster. And in fact, what I observe these days is that with Java workloads capable to start in a few milliseconds, the limiting point is now the performance of your platform, like how fast your Knative based infrastructure is able to provision the container image, start the container, and make it available via ingress for HTTP request processing. These days, with technology like GraalVM native images, the main reason for the cold start is the platform itself. So that's pretty interesting to see.
Yeah. So Glenn says, right, for a batch app, it doesn't really matter. It's probably got more to do with processing and memory and things of that nature. Again, it's understanding the trade-offs, the consequences for your particular need. And, I one of my soapboxes is when people grab the same tool, and I just use this tool over and over and over again. It's like, there's a reason we have all these different things. Now, the challenge for us is knowing kind of when to pick up which one and when it's appropriate to use this versus that. And not everything should be made a native image. Not everything should be running on a JVM. And I think that's part of what I find so great about this. One of the things, too, that I think people need to appreciate, with that native support being baked in now to Spring, you don't have to completely relearn a stack to take advantage of what's available now with native. I think that's a really powerful abstraction, and something that I don't know if that's quite gotten enough traction, attention. I mean, I know we've been beating that drum for several months, but I think people need to appreciate just what that enables, honestly.
Yeah, and one interesting thing is that it allows to basically convert existing application. In fact, so I don't claim there is no, you will be able to run every application on native unchanged, but the goal is basically you don't have to re-architecture your application. You need to add some ins, so some reachability metadata that will for the specific aspect that Spring is not able to infer, because Spring is inferring a lot of things instead of you. You may need to add a few ins to make it run, and when it's good, basically, yeah, your application should run almost unchanged. And given the huge number of applications already created with Spring Boot, I think that's pretty exciting to be able to try another kind of deployment with your existing application, modulo some work and testing, etc. That's super exciting. It's not just for new workloads; it's also for existing ones.
Right. Well, and it gives people a chance to test it out and see if it helps or not, and what kind of a difference it makes for them. You know, I think one of the frustrating things so often about software, and certainly my role as an architect, the answer I have to give to so many questions is it depends. And there is no one size fits all for every application or even every part of an application. You know, it seems to me that there are absolutely instances where, yeah, this should be a function or it would work really well as a function versus, no, this probably needs to be an app. And, you know, we need to have at least this many instances running at all times. You know, that's part of the fun of this for me, right? Is having those conversations and trying to figure out what is Goldilocks for this particular situation. And, you know, again, I think people get really locked into, I have to use something for everything. It's like, no, you got options, and you just have to know kind of when to grab one or grab the other, or I guess to play on.
Yeah. And we try to push a bit the boundaries these days, because to scale to zero. So I was last week at Spring IO. And in the keynote, I had the opportunity to present 3 ways to scale to zero with Spring. So the first one is the one we mentioned, the native image angle. But there is 2 new ways to scale to zero that we presented last week. There is a new feature provided by Spring Cloud Function that allows to deploy Spring Web controllers. So Spring MVC, Spring Webhooks add controller that people are typically using to create web application. And there is a new support to adapt those controllers to serverless platform like Amazon Lambda, Azure Functions, etc. And I think that's interesting because until now, Spring Cloud Functions supported basically functional interface bin, like you implement Java util function and you provide a function that you can deploy to Amazon Lambda. But in practice, most of those functions are deployed on HTTP. So I think that's pretty interesting to be able to leverage the existing well-known, super flexible, super powerful Spring Web programming model and just deploy your get mapping endpoint on or post mapping endpoint to Amazon Lambda, etc., without having to change your programming model. So this is something we announced. And another thing that we mentioned is a new GVM checkpoint restore support in Spring Framework 6.1. So this is also known as Project Crack, coordinated restore after checkpoint. And so people may a bit lost because there is, a few years ago we had no way to scale to zero,
right?
And now we have 2-3 ways to scale to zero.
Right.
But in a summary, in a nutshell, GVM checkpoint restore is the capability, thanks to a modified GVM, to create a checkpoint that will be that will create files that will be the memory representation of your running GVM, and be able to restore in a few milliseconds, potentially warm-up GVM that starts super fast. Obviously, there is some challenges involved, but the key point is that GraalVM native images is a way to scale to zero with some trade-offs, and GVM checkpoint restore with Project Crack is another way to scale to zero with the GVM, but another set of trade-offs. And I try to share some advices about when you can use one, when you can use others, and we are working on providing both capabilities in future version of Spring, so that will be interesting to see. I expect both to be successful, both to be useful for different set of use cases.
Right.
And we have the choice, maybe too much choice now, but
paradox of choice.
That's a good problem. That's a good problem.
Well, it is. And I think it gives us more flexibility and gives us just another set of these trade-offs. And so I put the link up here to your keynote from Spring IO from last week. I do think that's a really important thing to see how some of these lines have gotten blurry, right? For a long time, well, if you wanted to scale down to zero, your only option was a function. And now, well, I could turn that app down to zero, which there are still instances where that makes sense. You know, I've thought about some of the apps I worked on in my previous life, and several of those we would have been able to scale down to zero overnight because we just didn't have anybody hammering on it. That, you know, we still had core business hours. And so that, again, helps lower the cost on this, which I think is really important too, that if I can turn that down, that frees up some resource. I think about how much money we had invested in servers that were idle for, a significant amount of time. That's money we can then pour back into more features and functionality, which is typically what our customers care more about.
Yeah, and it's you don't necessarily have to scale to zero. We usually say scale to zero in reference to the serverless billing model, and also because this is the ultimate technical capability. But the key point to scale to zero is basically you are able to scale up super fast, start an instance super fast, and this is already super useful just with your regular Kubernetes platform, because if you take 30 seconds to start, maybe the Kubernetes may think that your application is a bit sluggish. If you can start your application in 2 seconds, that will be much better from the DevOps point of view. I think your customers will be happy because you will be able to scale up super fast. So imagine you have a strong amount of connection because somebody are talking about your website on social media, television, etc. If your application take 20, 30 seconds to scale up, you may be just destroyed by the incoming workload. While if you are able to start a bunch of JVM servers or native application for your Spring workloads in less than 1 second, basically, you can your run is more efficient. You don't necessarily have to provision 2-3 instances for each microservices just to have high availability. So I think even if you don't have to go to scale to zero, it just that you have this capability to scale up, scale down super fast, and you just adapt your platform to the workload, the amount of workload you need, and that just good practice basically.
Right. Yeah, no, I think that's a good point. I mean, I think about the way we've designed apps has evolved as part of this too. It wasn't all that long ago that your apps would take a very long time to start up because you'd go call the database a bunch of times, load a bunch of stuff into memory, and then that would just run because you didn't have to worry about having it go up or down. It was just going to be in this setup for the next day or two. I mean, maybe we rebooted overnight, maybe. But we have a different set of trade-offs now, and I think there are different forces working on our applications than there were before. I think about sort of, and I hate the word, but the influencers, where somebody gives a shout out to your product in the right spot, and you're going to see a huge increase in traffic, and you better be able to handle that, or you may lose that opportunity. And but it's good to know we have a bunch more options than we had, than when I started web development 20 plus years ago.
Yeah. And it also impacts the data services. I mean, I have seen some, if you have a look to the offering from cloud vendors, you also see that they begin to introduce scale to zero offering for data services like database, etc. Because if your application can scale to zero, but you have to pay full time your database server, what's the point? So there is a technical impact, and there is also an impact on the commercial offering for the data services, etc., where you may want a data service that have a pay as you use billing model, basically, and that's interesting. That also impact that side of the hosting.
Yeah, as Glenn says, it's just a different set of trade-offs here too, and understanding that you might be able to get more on the same hardware, but the consequences, your builds are going to take longer, and you might need to make some tweaks in your code in order to handle that. And that's software in a nutshell, is all about these design trade-offs. So I think, Glenn, the moral of the story here is I'm going to have to reach out to you, Sebastian, and others and try to figure out this little app I've been playing around with for the last few weeks. Does that benefit from being a native image or not? I don't know. I haven't even given that a thought yet. I'm getting pretty close, I think, to deploying this, and then I guess we'll see as the rubber hits the road. But right now, I'm just running it locally, so it doesn't really matter. But
and it's interesting that if you compare the runtime characteristic locally and in the cloud, you see huge differences, because we most of us have powerful laptops with a lot of cores, and basically, I can start my application in 1-2 seconds. And when you deploy that on one vCPU and 1 gigabyte of memory, and you see your application taking 10 seconds, sometimes more, it's not totally intuitive. So I think this is best practice for everybody to really have in mind the performance and the startup and memory consumption characteristic you have in production on cheap cloud instances, because nowadays financial service of companies are analyzing the cost of the cloud hosting, and basically they see various technologies. Oh, the hosting of Java application is maybe a bit more expensive, and so they check, and basically there is a move to try to reduce the size and the cost of your instances, so you get the cheaper one, and then your application take a lot of time to start, and then problem begins. So it's important to keep in mind the order of magnitude you have in terms of startup time and memory consumption on production.
So I've seen Deshaun do this where he'll run an app on the JVM and then show you how much memory it takes, how long it takes to start up, and then compile it natively and show the exact same data. And it's pretty remarkable how much of a reduction it is. And every time I've seen him do this, he'll poll the audience, how much time do you think it'll take? And, what kind of reduction would you expect? And I've never seen anybody get it right. They're always overestimating on both time and memory. Do you have any thoughts on sort of what you would expect to see from a native image versus, a JVM app in terms of how much of a reduction that you?
Yeah, so if you are trying to measure that locally, you will likely get it wrong, because the algorithm for allocating memory, for example, is super different between Mac and Linux. This is totally different. Sure. Typically, your local PC or Mac will have many gigabytes of memory. So again, here I advise to measure that directly in the cloud. And so when deploying on a 2 gigabyte instance with a small microservice, what I get is 5 times memory reduction after startup, after the first request. But this is for a small application.
Sure.
Because to be clear, the amount of memory that is consumed, the heap, etc., processing requests will be exactly the same between native and JVM, because you are still loading in memory the same objects. What is really different is that the native version won't have the JVM infrastructure, the GC will be smaller, you don't have the JIT, etc. So it's really, it's a fixed cost that you are paying, and with native it is smaller. So on big application, big monolithic application, you may see a bit of difference, but in terms of ratio, percentage, that won't be amazingly high. If you are deploying a lot of small microservices, the difference will be huge, because you pay a much lower tax with native for each instance you are running, both in terms of startup energy required and time for the startup, and in terms of memory consumption. So it really depends, and but that is a big difference for especially for microservices application. When you are deploying, you have split your big system into 10 microservices. That make a big difference. And also, like Glenn was mentioning before, you can just start with one native instance that will be maybe a bit slower than the full warm-up JVM. But if you need more power, you will just add another native instance. And the granularity where you will be able to scale, it's just more fine-grained. And again, that will be closer to your real needs. While a single JVM server with 2 vCPU, 4 gigabyte, maybe oversized for some kind of workloads that you need to serve.
Right. Yeah. Again, I think it's just very exciting because it gives us new options and new ways of exploring this. Now it means we got to do some more experimenting, and I think it's going to take us a little bit of time to kind of figure out on a given application, well, what is the best strategy here? Because before it was just one size fits all. We just threw it on the app server and that was that. And it was a big hunk of metal that our operators had running for us. And we got a lot of options now, which means we've got to work through those. But I think as we get more comfortable with that, as we have more examples of that, I do think we'll start getting a little better sense of how to balance those trade-offs appropriately. So thinking back on what it took to get Spring running natively, were there any things that stood out to you going through that process that you're like, that either you expected would be hard and weren't, or that you thought would be fairly straightforward and turned out to be more challenging? I think that's one of the things I love about software is this app I've been working on. My wife yesterday said, I need to be able to edit this. I'm like, oh, that shouldn't take very long. And that ate up my Sunday, was trying to get edit to work. So
I think it has been a pretty difficult journey, very, very interesting, but difficult. I think it took us, for at least 4 years of real work of a lot of people, because I mean, we started a few years ago with, I remember, with Andy Clement, Dave Sayer, experimenting on trying to compile one Spring application to native, and we achieved that using the Spring Foo project I initiated a few years ago. It's a functional way to configure your Spring Boot application. It was using just a subset of the Spring infrastructure, so that was easier to get that right. And I think we did that quite a long time ago. It was even before GraalVM reached GA, and that was the first Java framework, big Java framework to achieve that. But it's one thing to have this, okay, this very minimal application is running, and get production grade support for Spring Boot. It has been a huge journey. So we created this Spring Native project. Most of the Spring portfolio committers were involved. So it involved people from Spring Framework, Spring Boot, Spring Security, Spring Data, a lot of experimentation. We did 3 or 4 versions of the Spring ahead of time engine that basically transform at build time your Spring Boot application into something that can run efficiently to GraalVM native images. So very, very close collaboration with the GraalVM team. So we did a lot of things on a lot of work and improvement on Spring side, but we also had a very close collaboration with the GraalVM team, weekly meetings, in order to fix bugs on GraalVM side, introduce Maven and Gradle native build tools plugin that were not existing a few years ago. Introduce this GraalVM reachability metadata repository that basically provide native support for the most popular open source libraries. Nothing Spring specific, but Spring is the main contributor from that. And nowadays it's super, it is so popular that the GraalVM team sometimes struggle a bit to merge pull requests, etc. And so it's good problems, but this ball is rolling. This repository is super popular, and now the open source community want to provide support for their open source libraries. So yeah, it has been a lot of work, involvement from the whole Spring team, and in order to reach a level of quality that we call it production ready with the Spring standard, because there is a high expectation in terms of quality when Spring provides something. So when we say we provide native support, we need to do it right. We need to do it in a maintainable way and in a future-proof way. So this has been the most exciting project I have been working so far, and I'm super grateful that we have reached the production-ready stage with the inclusion in Spring Boot 3.
Glenn claims he also apparently added to the length it took because he asked lots of quote-unquote silly questions. So
everybody from the Spring team has been very super supportive. A lot of contribution, questions, feedback, etc. Crazy
and
work.
Spencer says hello. Hi, Spencer. Thanks for joining us, buddy.
Hi, Spencer.
Well, and I mean, I think that's part of this that sometimes people lose sight of. I mean, GraalVM hasn't even been around that long, and the idea that applications that weren't designed with this in mind, or architectures that didn't have this as a feature, there's gonna be some time, and I think it's a remarkable feat that the entire team should be incredibly proud of the effort and the work it took to get to this point. And I hope that consumers of Spring, the users of Spring, understand just how great that is, that it now is there and they have this option. And I mean, this is a very much tip of the hat moment, at least from my perspective, and I appreciate just what it took for y'all to do this. And I'm very excited to see now where the Spring community goes with this and what this does to our applications and how we build them and architect them. And I think it's exciting.
And interestingly, there is a big part of the work we did also applied to the JVM, and we have, on purpose, we have not been super vocal about that, but the ahead of time optimization that we built primarily for targeting native, in a nutshell, that basically transforms the annotation-based programming model into something based on Lambda, functional construct, etc., because GraalVM native understands that automatically. but it has also some benefits on the JVM, like a faster startup, reduced memory consumption. I think in the benchmark I did when we are using, so I had an application that started in 7 seconds on a small cloud instance with one vCPU, and it's starting in 5 seconds within the JVM using the ahead of time transformation. So
Sure.
there is something here where we do not I mean, it's documented. There is some constraint, like you need to define the Spring profiles at build time instead of defining them at runtime, because there is more stuff fixed ahead of time. But I think, yeah, in the future, we may also explore new capabilities, leveraging those ahead of time capabilities on the JVM to just provide more efficient Spring application. This is just the beginning of the story on that side. Just we need to be sure that there is a super compelling use case on the JVM to really make it first class. But nowadays, people can try it, and you can, if native is going too far from your taste, you can just create containers that are using the Spring ahead of time optimization. There is now documentation for that, and that's a pretty safe way to optimize the runtime of your Spring application.
Sure. Well, again, as Glenn said earlier, and I missed it. Sorry, Glenn. There's no panaceas here. It's just you've got options. You've got JVM, you got native, we got a lot of different ways of doing this, and maybe it is a paradox of choice, but I think it's a good problem to have. Now, one thing I want to bring up, and I'm curious with both Spencer and Glenn here. I know when Spring Boot 3 and Spring 6 came out, there was some consternation for the fact that you all baseline now on Java 17. And I looked at that and just kind of shook my head and said, well, who's still running old versions of Java? And then I was actually on a client call a couple of weeks ago, and like, yeah, we have some stuff that's not even on 8. And you're going, oh, yeah, okay. Yeah. But by the same token, I don't know what choice you have. I mean, you can't continue to support everything. I mean, there has to be some line in the sand, and I can only imagine how much more challenging some of this work would have been if an effort had been made to try to make it run on 8.
Yeah, and I mean, if you are afraid to switch from Java 8 to Java 17, it's maybe that you are not ready to switch to native, because switching to native is an even bigger change. So usually when people ask specifically for native, isn't it a problem? I think it is not, because yeah, native is a much bold choice and bold change than just upgrading. It's true that for production, I mean, real production, real customers with production constraints, etc., maybe going away from Java 8 could be initially perceived at challenging. And when we took the decision with the Spring Framework team, Jürgen, etc., to switch to Java 17, it was kind of ambitious, because that was just after Java 17 being released, and some people may thought it would be too disruptive. I think, yeah, with the Java support that is basically finished for Java 8, it's very difficult to get real support right now with Java 8. Yeah, I think this was the right choice, especially given the fact that we combined it with the Jakarta EE migration, because this is another area where we don't really have the choice. I mean, Java X package are not used anymore in the latest Jakarta EE release. All the Tomcat, GPA, etc., have migrated to using Jakarta package. And so, yeah, basically the principle was, okay, we are going to have a big ask for our customers and users. So let's try to combine Java 8 to Java 17 and Jakarta and Java X to Jakarta EE, and let's try to provide as much help, documentation, etc. On that. And I think we did a pretty reasonable job. Spring Boot 3.0 provided full Jakarta migration in a very short amount of time. I mean, that was quite a few months ago, and at that time it was really challenging to get all the dependencies used by Spring Boot available on Jakarta. So, and yeah, and Java 17 is just a baseline where we can use Java records and other very nice language feature in all Spring examples, etc. So the feedback I see from customers in 2023 is very positive. Last year, a lot more people were a bit wondering if that will be realistic.
Sure.
But
Sure.
yeah.
Well, as Glenn points out, 21 is right around the corner. So,
Yeah, and the Java platform is moving faster. I mean, there is
right.
virtual threads, there is checkpoint restore support around the corner. So, I mean, yeah, the Java platform is moving faster, and we try
Yep.
to. I think with this baseline is really for Spring Framework 6.0, 6.1, and future versions. So it's basically defining the baseline for the next 10 years. So we are really at the beginning of that period.
Right. Right. Yeah, I think that's a good point. And, I've thought a bit about this, and I think a lot of this is cultural, to convince people that they need to invest in some of this basic maintenance. And Glenn sort of inspired this analogy for me. You wouldn't get on an airplane if the airline said to you, we haven't done any maintenance on this plane for the last 5 years because it's working. So we didn't want to touch anything. We didn't want to break anything. And yet that's the attitude we take in the software that, I didn't want to touch it because it was working. We didn't want to break anything. And I feel like that attitude made more sense maybe 20 years ago when essentially the entire organization was making the decision to move to a new version of Java because we had to wait for the app server to support it. And we always had that one lumbering application that couldn't make a change, mostly again for cultural reasons, sometimes for good reasons. But I don't feel like we're in that space as much anymore, where these apps should be able to move more, where if you've got an application that needs to stay on an older version, they can do that without harming, so to speak, the rest of the organization.
Yes, a lot of organization. I mean, when I worked several years ago on that, I mean, there was the team responsible for the DevOps operation, the developers, and the developers need to add the approval of the DevOps team to upgrade the Tomcat version, the Java version. Spring Boot really changed the game by just making the no app server anymore, and basically the developer is responsible for the servlet container version, etc. And I think the Java version that is bundled in your container with Buildpack or Docker files or whatever, it continues the move in the same direction. I mean, it's part of the developer choice in agreement with this company rules to choose the Java version. It's basically an implementation detail of its container. And the DevOps team is just running a container without being in control of everything in between. And so, I think nowadays with more and more workloads running on containers, it's easier to be in control. But of course, there is a huge amount of existing applications that are running on not legacy, but it's historical infrastructure where it's just a very big event to upgrade the Java version. And
historical. That's a good version. I use heritage, and I know Deshaun's got another term he's been trying to get me to use. So good afternoon, Deshaun. Thanks for your ears must have been burning because I used your name in vain earlier. So, and I appreciate that, right? I mean, I understand there's lots of constraints, but I feel like in many cases it has more to do with fear than anything else, and just concern about, oh my God, the whole world's going to come crumbling down if I make this change. And I mean, sometimes you just got to kind of rip the Band-Aid off, because there is a cost to remaining on the historical or heritage or legacy variation. And we got to appreciate what that cost is. It isn't free. And so, you're losing out on some of these things if you're going to stay on old versions.
Yeah. And most of the time you can just run your application design for Java 8 on Java 17. The main impact may be the Jakarta EE migration because of the package change. But otherwise, I mean, most applications, especially if you are using Spring Boot, where we are doing a lot of work to ensure compatibility, etc., it works. And you have supports while on Java 8. You are a bit... I would not trust running Java 8 unsupported on production right now. So I think that's a safer choice. And if your workload is already containerized, should not be that much an issue.
Yeah, no, agreed. But I mean, it is hard to change that. And I know one of the things that we all run into is that's how we've always done it, sort of conundrum. And we get stuck in that way of thinking that, well, that's how I have to continue to do it. And maybe not. Don't be afraid to ask, why are we still on this version, and what is it that's holding us back, and are there another approach to this? So let's see. Simon says, legends say if you say thrice, my children deploy active passive, that Okay, so that's apparently about Deshaun. So apparently we said something about active passive, and that must have made Deshaun show up. So well played, Simon. Oh man, it's going to be really interesting to see where this goes. I mean, do you have any thoughts on what you think the next 1 year, 2 years? I mean, I don't want to try to get too far ahead because predictions are notoriously difficult, especially about the future. But what do you think's the next step or the next big shift we're going to see?
So yeah, I have a pretty opinionated vision of that, and I think the next. So we are really talking about middle long term. I'm not talking about tomorrow. Tomorrow is just leveraging native checkpoint restore, etc. And there is a lot of things to do to be able to run our workloads in a cheaper and more sustainable fashion. And yeah, there is a lot to say there. But for middle long term, I really believe that basically containerless application using WebAssembly to deploy workloads could be the long-term future. I'm personally involved in WebAssembly for quite a long time, and I'm pushing that since 2016. At that point, nobody really understood why it could be interesting for servers, because that's a technology that has been designed to mainly run native workloads in the browser in a secure fashion, etc. But with Docker recently supporting WebAssembly workloads, with Kubernetes being able to integrate WebAssembly workloads, and with more and more languages being able to compile to WebAssembly, I think this is an interesting thing, because that allows you to deploy a workload that is, let's say 100 times smaller. You have no operating system involved. So in terms of maintenance, security, much better. You can really instantiate workloads per request. So you have a microsecond instantiation time. So here we are not talking about taking 1 second to process some workloads. It's just you instantiate your workload per request, and you don't care about the rest. So just the next level in terms of security, scalability, and just a nice compilation target for workloads. So I tend to think, at least if I have to make a bet for the middle long-term solution, I would say, deploying containerless application with WebAssembly and related standards like WASI, etc., is my at least my hope. And it's interesting to see that Java does not compile. I mean, there is some project that compile to WASM, but not yet totally usable. Kotlin has a dedicated version of Kotlin WASM, that targets WebAssembly. And I have recently created an open source project which is called CoWASM, so cowasm.org. And you can basically run server-side workloads, run them with Docker, with 100 kilobytes size, and it runs super fast, etc. So I'm already showing that with Kotlin it's possible to run those workloads. And so if Kotlin can do it, I guess Java can.
Right. I mean, that's one of those interesting things to me about our space, is it constantly evolves and changes. And I guess it's good for those of us that have short attention spans, because there's always going to be another way to do it. But so you've brought this up a few times, but you've obviously been heavily involved in open source, and Glenn, I know, has thoughts on this as well. Fuel Snable finally showed up, so we've got our Nordic contingent here. Good evening, Fuel. Sorry, I almost forgot my time zones. Do you have any thoughts, advice for anybody who really wants to get involved with open source, wants to dip a toe in that waters, but has like no idea where to start, or they're really intimidated by, I don't know enough about whatever project they're interested in to even bother to offer any help? I mean, what would you do, or what advice would you give to somebody who's new to that space?
I think I would maybe advise, so speaking about, for example, the Spring community, it's much easier to contribute at guide, documentation, or maybe sometimes boot level. On framework level, it's usually issues that require a lot of historical background, etc. While maybe because we are just at the core, while if you are more at the integration level, it's maybe a bit easier. I mean, there is a lot of work that is super hard on boot, but there is maybe some issues that are sometimes, I think, identified by a specific label on the Spring Boot issue tracker that allow you to identify issue where a beginner can contribute more easily, while on the core that's maybe harder. So I mean, just also contributing in terms of answering question on Stack Overflow,
Right.
creating various samples, and contributing to documentation, and just contribute to use cases that are impacting you. I mean, myself,
Yeah.
I'm just working on issues that are interesting me as an application developer,
Right.
and that's where I think I am the most relevant. So, I mean, if you feel an issue, if you are seeing something that is missing, just try to create an issue,
Right.
or see if there is existing issue where you can bring some value, and that's I think that's super important.
No, that's a great point, because there's a lot of things where you can't test everything. You can't, there's no way that we can know of every possible scenario, and so somebody might be running into something that the Spring folks didn't see, and then, hey, throw it out there. What's the worst thing that can happen? It might really help things out. And yeah, as Glenn says, review the Spring docs.
Yeah,
that's a great way to get started, and it's very valuable. I mean, this is a conversation Glenn and I've had more than once. People don't appreciate how important it is. If you see even just a typo, or this command's not quite right, submitting that fix saves probably hundreds of people, if not thousands of people, a lot of time. And that's a big deal, in my opinion.
yeah, and basically making the work on really checking if there is existing issues when you provide issues, providing a repro project that allow easily to reproduce, etc. I mean, yeah, as an open source contributor, we are integrating a lot of peers. We are reviewing a lot of peers, so it really helps when people have taken the time to double check various stuff and providing samples. I mean, it's not about being an expert and anticipate everything. It's really about providing an easy way for us to provide feedback without having to create a project from scratch, etc.
Right. Oh yeah, no, Glenn has another good point. Is there a test that's missing? Is there a use case that's missing?
Yeah, adding a test, even better than a repro, adding a test to the framework that allow to reproduce that issue. That's super useful.
Yeah, no, one of the things that I've actually been talking to Dan and Sean about is, because Spring has been around as long as it's been around, when you Google something, you find a lot of answers, and it's really hard, especially for someone who doesn't have 20 years of experience with it, to know, well, is this the right way to do it today, or was this the right way to do it 5 years ago? And it turns out there's a better way, or I mean, better is maybe the wrong word, but a more modern way of doing it. And I think that's one place where having a new set of eyes and being able to say, well, is this really right? Is there another option, is incredibly valuable. So, oh, and Fuel says we should just ask Chat GPT, and it will answer all of our questions there. Yeah, and then migrations as well is another part of this that's important.
Yeah, we are in the process of migrating the documentation to Antora, which is basically a system that allows us to provide a built-in search engine and much better capabilities to be able to find the right information without having to Google it. So this is in the process of being integrating into the various project, and Spring Framework has recently been upgraded to leverage Antora, and I think this documentation with search capabilities built in will really help a lot, because I guess we were all used to go to the single page documentation, Control F, and then search. And how do you do when you are on mobile? And how does it basically consume so many megabytes in your browser? So we just have better solution now, and that's time to leverage that.
Right. We have other options. So Fuel makes a good point. With all the new stuff, you may have new tech comes out, you may not like it, and if you just wait long enough, everyone else will stop liking it too. And there is some truth to that, although the counterpoint is, what's bad is if you enjoy something and it's going away. I mean, that is inevitable, I think, in this space. I think I first heard this from Neil Ford, but today's best practice is tomorrow's anti-pattern. I think we've certainly run into that. But so oh, that's a good point, Simon. Single page version was definitely nice on Kindles and other devices for access on an airplane. It is interesting how we keep adjusting those things. But Anyway, well, let me wrap up with just a kind of a general, we'll shift gears here a bit. Is there anything that you've been reading or watching or streaming or listening to that you found really interesting, helpful, useful, anything that kind of helps you get out of staring at screens all day long?
You mean related to Spring or in general?
Just in general. I mean, so is there anything you've read or listened to or watched that you're like, oh wow, that was really cool, and other people should be aware of this?
I mean, I keep, I keep following very closely the other ecosystems because I'm not just a backend developer, Spring developer. I like to follow very closely what happened in the JavaScript ecosystem, for example, with this move to basically try to do server-side rendering more and more and try to introduce. It's not just a move from front-end traditional client-side application to server-side. It's a move to basically try to provide a unified technology that by default render stuff at server-side because SEO, because you need to have a fast rendering time, and then just ship the dynamic bits executed on client side and get a framework that do all this magic to determine automatically what is server side, what is front end, and get a kind of unified thing. Currently, that's only possible with JavaScript, but again, with WebAssembly, we may see that on other technologies. But generally, trying to see example of this kind of evolution where you are breaking a tech silo between front end and back end, for example, and you are basically changing the boundaries, or what happened in AI, ML, and Python world, basically, with Python used for the glue and all those crazy C++ libraries used for implementing that efficiently, and how other languages will try to catch up in this crazy AI, ML world. I mean, there is so much going on. It's hard to follow everything, but I like to take inspiration. I'm not an expert of every language, but trying to get inspiration of the big tendencies in other technologies and try to see how that can apply in our world. That's an area of interest. On a more personal note, I like to play Trackmania, so I'm a big big fan of playing online this game. So this is what I do on my spare time. And otherwise, I just go outside and do various sports, etc. But
Nice. Let's see. We have okay. So Fuel says he watches me stream, which I guess is nice to know. I appreciate that, Fuel. It's always nice to have you here. And I love this one. So Glenn wonders if you would do voiceovers for his presentation because you would make them sound more elegant, and eloquent, and professional.
Not sure you want my French accent on your presentation, but up to you.
There's a lot of folks who find the accents to be incredibly, seductive and powerful. And I don't know. I mean, I was just in London and I was talking with a friend of mine from there, and Love Actually came up, and there's that scene where a British guy flies to the U.S. because in England, in America, I have an accent that I'm obviously amazing, and that's obviously the script. That's what happens. And so I said, yeah, I think sometimes having an accent can actually be hugely beneficial. So.
True.
Let's see here. What else we have? Glenn loves your French accent, so and I agree. I
Thanks,
think it's made today's show much more elegant than it normally would have been. But well, I could continue to talk your ear off, I'm sure, but I know it's late for you. I will give one more plug to your Spring IO keynote. I do think it's really important to understand that it's getting blurry now, this idea of functions and apps and when should we use one or the other. And I think, again, it gives us yet another abstraction that we can leverage. But I do think that's an important piece of this equation. And I think it's been fascinating to spend today chatting with you about Graal and all the trade-offs with native images. And I really appreciate your time, man. Thank you so much.
Thanks for inviting me.
Yeah, well, thanks for hanging out with me, and we'll be back. Let's see, who do I got coming up here? And see, double check. We got a comment, something smaller. Where did it go? Something smaller than a function. Well, I mean, eventually, I suppose they'll have to be micro functions or something. I mean, we keep trying to jam these
nano function, maybe
nano pico. I don't know. There's probably there, and yeah, I agree, Simon. I think it's pretty remarkable that they've managed to churn that out because that was just the end of last week. So kudos to them for getting the videos out that quickly. But let's see here. We will be back. I back next week? I think I'm off for a little bit because we've got a little holiday here in the US. So I've got, this is sort of my month of spring people. I had Olegon previously, now you, then we got Sobi. So we're going to do our best to get through as many spring committers as possible before this all goes down. Oh, is that a single line function? I mean, you could. I'd argue functions are supposed to be small fuel. That's kind of the idea. If you've got tens of thousands of lines, I don't think it qualifies as a function anymore, but you know, it's all in the eye of the beholder, as they say. All right. Well, thank you again, Sebastian. I really appreciate your time, and have a good evening. And I hope we'll see you later this year at Spring One at VM World. Otherwise, I hope our paths cross next time I'm across the pond. Thank you.
Okay, bye.
Cheers.